So I'm responsible for the EMEA region, and there's a global race in AI going on. And so I thought we can be really proud of our region as well if you look at our recent history, the great innovation that came from the region. So I wanted to start with a little 2-minute video to give you a short intro in what we see in front of us.
It began here. The first industrial revolution. Watt's steam engine and the mechanized loom introduced automation and the advent of factories, and industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator, and Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot gyms, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began.
So a nice video to get us going, and we make this video every 12 months to show the great collaborations that we have. So it's not just ideas that we have, these are partners that are working with us to implement these projects. And when I'm visiting a country like we are doing here, over the next few days we have a couple of meetings. My question is always, who here in the audience will be part of the video next year, right? Will we have your project, your showcase that we can bring forward? And yeah, we talked a little bit about the Industrial Revolution. And the Industrial Revolution, I think Europe was a true leader in there. And when it comes to inventions, right, also here in country, brilliant inventions have been made. And so there are great examples that we can take from there. Some countries really embraced it. They became leaders for decades. But we also have seen countries that couldn't keep up, or they didn't even get started, and it took them decades to catch up. That whole situation exists again, but it's just going a little bit faster as we're moving now into the age of the AI revolution. But now with the AI revolution, it's no longer about creating electricity, about coal and steam and so on, and creating these factories. It's now about AI factories. And we talk a lot about AI factories, but I think it's good to stop one moment and think about the definition of an AI factory. An AI factory is not a data center. In a data center, we have applications and we store stuff. In an AI factory, we create intelligence. Intelligence in the shape and size of tokens. Quite important to realize. We take electricity, we take local data, and then we turn it into tokens, and we generate intelligence, value, faster time to insight. And for us, it's quite relevant because we see an AI factory produces things, and it's unlocking trillions of dollars of economic value. That's why an AI factory is so important. Then, if you look at the different waves of AI, and it also tells you something about the speed. I started 12 years ago. About 10 years into the journey, we saw that deep learning was taking off, the renaissance of AI, with something called AlexNet, deep learning, a new way to compute. By the way, we learned there as well that innovation doesn't always happen at a very large scale, but it can happen across the world. It can happen with a few researchers together. So we're always on the lookout to see what are researchers doing, what are startups doing. It's not just about the biggest organizations. We've learned that from AlexNet. Perception AI took off. We saw great progress inside of medical applications. And then there was the generative AI moment. We don't only analyze, we can start creating. And so we have seen the ChatGPT moment, and everyone was amazed what happened there. But now we're moving into the domain of agentic AI. Agentic AI, no longer we're just being provided with some text or a proposal. No, an agent can take action on your behalf and complete the full process. And also there we now see kind of a ChatGPT moment happening. Agentic AI, not a new concept. We've been working for 2 years very strongly about it. But now suddenly everyone has access. If you heard about OpenClaw adoption was steeper than ChatGPT. And OpenClaw is not easy. It's not for the faint of heart to get started with. And now we see under that accessibility of OpenClaw that suddenly in the bigger tooling, like OpenAI's Codex or what you can do with Cloud Code and CoWork, suddenly agentic is available for many of us. And the adoption is going very fast. And then the question is, what can it do? What can it do for the enterprise? That's happening right now, and is happening at full speed, bringing both opportunity and challenge to all of us. And then there's this bigger next wave. We think it's even bigger than everything we see right now, and it's in the domain of physical AI. And I'll talk to that also a little bit. That's about AI interacting with the physical world, the environment around us. Now, what does NVIDIA do? NVIDIA brings a platform forward, a platform for all of these types of AI and for all kinds of situations, whether you want to work on agentic AI, whether you're a student or a startup that wants to leverage open models, we do all of that. Whether you want to go large scale with AI factories, whether you want to build self-driving cars or robotics, we create one platform for all of these scenarios, and we want to bring it as open as possible, with a strong emphasis on the software there as well. Now, since we're talking about AI factories, I also wanted to show you that an AI factory is a complex beast. When we say AI, there are still quite a number of people that say it's about a chip, or a single chip, or NVIDIA is a chip maker. Well, we are, and we are not. AI is more complex than a single chip. And 12 months ago, when I was on stage in Tallinn, and we'll be talking about 6 amazing chips that come together. And just 8 weeks ago, we announced the 7th chip. And so there's a lot on compute. But NVIDIA also invested in CPU compute. And we're the largest networking company in the world as well, because it turns out that if you can't combine all these compute capabilities together, you can't progress to the next level. And we introduced new computing models as well, as we licensed the Grok LPUs. But one thing that's also absolutely crucial is the software layer that comes on top. Because if you don't have the software that helps you with the traction to leverage things like a brilliant AI factory that Orion brings in place, then it's hard to progress. So it's a public secret that most of our effort is in the software development side of things. We have around 40,000 developers worldwide. 80% of those are focused on software. So if anything, an AI factory is about utilizing these software building blocks. As AI is ramping up, something else becomes important. I already introduced the topic of a token. The topic of a token, we're creating value, we're creating tokens. And so as a leader of an organization, you start to think, okay, what kind of value am I creating with those tokens? What's the value of those? And the others, of course, what's the cost to produce those? And as the technology is moving faster than any other technology we have ever seen, we see tremendous leaps forward in the efficiency. So both when it comes to the energy required to produce tokens or the capital needed to invest in those tokens, is going down like nothing we have ever seen before. And both the technological progress and also the economic benefits make it now possible to adopt AI at a scale not seen before, driving new innovations like agentic AI, where you see 100 times more tokens being used compared to just generative AI, or also the opening into physical AI, where we need to simulate a lot. So this mechanic is very good to understand why AI is moving forward at such a tremendous speed and why it's economical viable. And here you see a setup of the modern AI factory, the latest generations. And it makes you wonder, why do you want to establish a sovereign AI factory? Why do we care that a country brings this in place? Well, we think it's absolutely crucial for every organization and country to be a master of their own destiny, to create the capability to drive and adopt and to prosper based on AI. Because one thing is to take your data, ship it off somewhere, and then to buy it back later on. But it is also good to have the capability to use your own data, to use your own energy, and then translate it into value while keeping your cultural values, while supporting your local language. And I think by doing all of that, we can move faster. And it is definitely an engine for economic growth. You need to have this in place to support the AI community, to keep the talent, of course, in the region. But also think about scientific discovery. Europe has been big in discovery. And an AI factory is nothing less than a tool that you would require for any scientific discovery. Think of the microscope in the past, or the telescope, or a particle accelerator. An AI factory is what's needed to unlock the next steps of discovery. And we see fantastic evidence in this domain where, let's say, material sciences, so many new materials have now been developed over the last 2 years. And this is how we create more progress. And of course, also on the public sector side, where we have been engaging with many governments, it's to improve, of course, the interaction with the public. It's to work on sustainability as well and solve problems like the electric grid, how to optimize that. And of course, national security is also an increasing topic where AI and having an own sovereign AI factory becomes quite critical. So all of this together makes it an important topic to drive this on a national level. Is that message well received? Yes. Yeah. In the global race, I saw our region a little bit behind. There was a lot of vision and a lot of talk of what would be possible. But luckily, over the last 12 months, I would say many of the key governments have been moving from just planning into execution. And you see examples here of the UK, Germany, where we introduced a large industrial AI cloud. You see France there, but also the smaller countries we care very much about. And you see an example of Denmark there. And if you then look into the different initiatives that exist, I'm so happy to see now an AI factory come into place here in Serbia as well. It's absolutely critical to move forward together. I'll leave it to Orion to go further in detail on the factory, but it is this important keystone that is being brought in place. And I'm also very happy to see that it's on the latest Blackwell technology, right? Not something that we see that has been mainstream, no, latest technology is being introduced. Now, what's happening in compute availability then in the region? A couple of years ago, I would have said it's not good. If you're a startup, if you're a researcher, and you're looking for resources to get your job done, you would not find them. Same as here in the region. If you would need Blackwell technology, it was not available until Orion moved forward. Now I see the execution moving and the growth is there, resources are being brought in place. However, I see also that we should not be complacent because these are good first steps. But in this race, to keep the momentum and also to think about how do we adopt fast and move to new technologies swift, that's the real challenge. I spoke about physical AI being the next fantastic opportunity in front of us. I think it will be bigger than everything we have seen before. So I think it's good to spend a little bit of time on this. Physical AI for us means that instead of having agentic and generative, we'll have AI interacting with the physical world around us. And there will be sensor input. We can give it, of course, commands and prompts to do specific things. But there will be action in the real world. That action will find its way in all kinds of different robots. And you need to think a little bit wider about the concept of a robot. Because a robot can be a complete factory. The whole factory is a robot that can work autonomously, understands all the sensor input, understands all the devices that are in there, and the cameras and all the vehicles moving. It can also be a robot, because suddenly we see with the capabilities that exist today that humanoids become very viable. And so a robot is an option, but it could also be a moving platform inside of a factory. And then autonomous vehicles. Quite some exciting development happening in that domain. NVIDIA is doing a lot of work, for example, together with Uber and with Bolt and with Daimler and with Jaguar Land Rover. And so these vehicles you will see coming to our streets now. Maybe resolving some of the issues that we had coming here today. Now, why is this happening? Because a lot of people think that robotics is not new. Why do you think, NVIDIA, that this will take off like we have not seen before? Because 3 challenges have been solved at the same time. 3 challenges that have existed a very long time in the field of robotics. The first one is you need to train AI models that are extremely advanced to, for example, power a humanoid. With these AI factories that exist today, we have the ability to create extremely advanced models that can go in there, or a self-driving car. I think everyone understands the challenges there. Then the second thing is you need to deploy these very advanced models inside of an autonomous platform. So it needs to be very powerful, but also super energy efficient, because the platform is moving around. We're there. We have solved that problem as well. A third challenge remained, and it turns out that the AIs, just as humans, we can go to university, but the real world then turns out to be quite different, and there are all these corner cases. So we need to learn in the real world. And that turned out to be very hard. And so we found a great solution for that, because we can simulate the real world at extreme fidelity, so mimicking the laws of nature. And we can do that at a scale not seen before, and we can do that in parallel with many instances, and we can also do that in super time. So suddenly it becomes possible for these AIs to learn a lot very fast about the real world, but makes them more suitable once they come into our real environment. Those 3 things, now for the first time, are coming together, and that's why you see the uptake in physical AI. And why is this also interesting as an economic opportunity for all of us? Just look at the numbers here. There are 2 billion cameras in the world. There's over 10 million factories. And today they are not very much automated with either AI or through the autonomous robotics. Fantastic opportunity. There's 200,000 warehouses. And now you can also see our interest in autonomous vehicles. We just look at the sheer numbers and the problems that you can solve by having more optimized transport. And the humanoid opportunity, if you look at the scale, it's billions of humanoids that can be deployed. So a very interesting outlook just in front of us. And the question for each region, each industry is how do you tap into that? And are you involved, or will you just look and see how this will evolve? It's nice to talk about it, but it's always better to show how we are using it ourselves. And as you know, NVIDIA has a very strong demand for its technology. We are a partnership company, so we have worked with our supply chain to take all of these technologies and put them to use into meeting the tremendous demand that we have outside. One of the issues that we have is we are creating more production capability, but it's very hard to find labored skill and to just ramp up that production as well. So here you will see an example of our partner Foxconn, who has created the next generation of factory that develops the building blocks for our own AI factories, which will end up here. And we use simulation, one of those pillars that I mentioned, to simulate the factory even before the first spade goes into the ground. And it's not just a simulation, it's 100% physically accurate. So most of the problems that will exist in real-world deployments, you already find while you're doing this. Then we have all kinds of robotics inside of that factory, and all those robots, they are being designed, they're being planned, they are being trained inside of the environment. And here you can see how we can simulate, and also all the sensor input. You can simulate the cameras, you can simulate the sensors. You can simulate how real people will also be in that environment. And then there's, of course, also AI that will help the people inside of the factory do additional quality control, support them with some of the decisions that they need to make, and of course, keeping the people safe there as well. And so I think this is a great example of how physical AI is now being implemented very fast by the ones that are embracing the technology. I have another one here on physical AI in self-driving vehicles. Very complex challenge, and that's why we like it a lot. You have all these different models. Here you see a reasoning model that we have open sourced as well, and the car can reason about what it will see. The great thing about reasoning is that it can handle also situations that the physical AI didn't see before. So it will reason itself out of the situation. And so here you can see what happens with a scenario that it didn't come across before. And you can, of course, give input. I think we all like this. Can you go faster? Yes, of course. This is not a test vehicle. You can buy this now in the US. You can buy this Mercedes CLA with this level of automation in there. And there are tremendous other possibilities. And here you see not only the hardware side of things, but here you see a couple of the libraries that are being used by developers when it comes to real-world physics simulation, reasoning technology in there, models that can predict what will happen in the real world if you manipulate a certain item. And here you see all these use cases. So, big opportunity coming towards us, but the key is, of course, AI is great, but it's a technology game. If you don't have the technology in country, if you don't have it at hand, if you don't have sovereign capabilities, you can't even get started. And so we're very happy to be here today with the implementation of not only the AI factory, but also the first evidence of real-world projects when it comes to having a localized LLM in place. So I want to thank Orion and everyone supporting, and Marco, Michaelo, and Slobodan for making this happen. And we're here to partner up with the Serbian ecosystem. Thank you so much.